Uh, Hello everyone. Today I'm presenting our new project. This project is basically about the EcoCampus AI. The name of the project is EcoCampus AI. This project is basically the campus energy intelligence and emerging technology-based solution designed to improve energy management and sustainability in a university campus. The basic problem is simple. A campus has multiple buildings, different operating schedules, and continuously changing energy consumption. If management only receives an electricity bill at the end of the month, it can identify the cost, but it cannot easily identify where energy is being wasted, when the problem occurred, or what action should be taken. EcoCampus AI addresses this gap by combining IoT-based data collection, real-time monitoring, analytics, anomaly detection, prediction, and AI-supported recommendations. I will now demonstrate how the information moves from data to management decisions. So for the further explanation, I would like to invite Meet for the further explanation. Yes.
So thank you, Shreyas. Now I'll be telling about the dashboard management's first view. As we can see in this EcoCampus AI dashboard, the first layer is designed specifically for the management. Instead of showing raw sensor data, it summarizes the all over campus through by each of the performance indicators. And later in this prototype, as we can see, today's energy at 2350 kilowatt per hour, and the today's cost is 18,600 rupees. The carbon emissions are around 1.8 tons, and the sustainability index is 82 out of 100. So now for the next part, which is the live energy consumption. So in this, we can see that the graph which it is showing the campus and the consumption which is changing over time, and it is our prototype, the smart meter, because it is continuously being poured by the data, and it is simulated and updated every 2 seconds. The purpose of this live energy consumption board is to demonstrate what the real-time IoT energy monitoring would look like, and we can also see a button to send the IoT data to the Firebase. That represents that the cloud component of our architecture, where the sensor data that is accumulated can be stored and subsequently analyzed further. And in the campus, the implementation of these type of simulated readings could be replaced by the actual smart meters and connected to each of the particular buildings within the campus. And the management could benefit in significant ways, as instead of waiting for the monthly consumption reports, the faculty or the facility members can uh, at every second they can constantly monitor, and they can identify the potential consumption of each of the building. And this changes the management and the approach style from reactive energy management to proactive one. So now for the Firebase one, I would like to call my friend Varun to explain further.
Thank you, Meet. Now we will briefly look at the Firebase Firestore, which is at the back end of the our website, which provides a continuous individual records, including building name, consumption, maximum limit, timestamp, and units. This allows the dashboard to retrieve and process live data, making the a system a connected data pipeline rather than just a static dashboard. Next, I will be looking at the live building monitoring. Here we move from campus level information to individual buildings. For example, the prototype shows hostel at 54.3 kilowatts, laboratory at 88.6 kilowatts, library at 45.7 kilowatts, and academic block at 80.5 kilowatts. Each building is also compared against its normal maximum threshold. This is important because total campus consumption does not tell management where the problem is. If the laboratory is operating at 88.6 kilowatts against normal consumption of 80 kilowatts, management can prioritize the laboratory for investigation. Therefore, this model supports a very practical management decision. Where should the facility team focus its attention first? This is an example of how emerging technologies can improve operational visibility. Next, I will call upon Jignesh to continue.
So the next stage is AI energy anomaly detection. So this is where the system moves from simply showing data to identify a potential problem. For example, the library is shown with a consumption of approximately 101.1 kilowatt compared with a normal maximum of 55 kilowatt. representing an 83.8% deviation. The academic block is shown at approximately 94.3 kilowatt against a 75 kilowatt normal maximum, while the hostel is around 110 kilowatt against a 65 kilowatt maximum. The system therefore flags these cases as a critical and generates an initial recommendation. Importantly, our current prototype uses threshold-based detection approach. It is not claiming to be a fully trained machine learning model. So in a production version, this could be an enhanced using historical IoT data, occupancy, weather, academic schedules, and machine learning model. So from management perspective, anomaly detection helps in various ways, and also management can make better decisions towards it. So next slide would be explained by my friend Simi.
Simi, I think your mic is mute.
Sorry. Thank you, Jignesh. So, after understanding what is happening now, the next management question is what is likely to happen tomorrow? This is where we use the Energy Prediction Center. The prototype predicts tomorrow's energy requirement at approximately 2531 kilowatt hours with a displayed forecast confidence of indicators such as expected electricity cost, expected peak demand, and expected carbon emissions. The system then provides a 7-day energy forecast. In the example, like shown here, daily predicted consumption is roughly between 2469 and 2565 kilowatt hours. This gives management a forward looking view. For example, if we predict peak demand is expected to increase, management can plan operational changes before the peak occurring hours. The current prototype uses recent consumption trends. A production system could incorporate historical energy data, weather, occupancy, and academic schedules to improve forecast. So the technology is moving from descriptive analytics, what happened, to predictive analytics, what may happen next. So now I would like to invite Varun for further explanation.
Thank you, Simi. Now we will explore the AI recommendation engine. The most important part from a management perspective is the AI recommendation engine. Because identifying a problem is not enough. Management needs to know what action should be taken and what could be the potential business impact. At the top, the system estimates potential monthly energy savings of 8,738 kilowatt hours, potential cost savings of 69,201 rupees, and potential carbon dioxide reduction of approximately 7,168 kilograms. Let's take the library as an example. The system identifies current consumption of approximately 105 kilowatts, compared with an expected maximum of 55 kilowatts, creating an excess of around 50 kilowatts. It then recommends using HVAC operation after closing hours and introducing occupancy-based lighting. The important point is that recommendation is connected to measurable outcomes, energy saving, cost saving, and CO2 reduction. For academic block, the system recommends consolidating low attendance classes and moving HVAC and lighting towards occupancy-based schedules. For the hostel, it recommends optimizing common area lighting and monitoring HVAC usage during low occupancy periods. And for the laboratory, it recommends reviewing high load equipment and optimizing HVAC operation during non-operational periods. Therefore, this module converts analytics into an action plan. I would like to call Shreyas to continue.
Yeah, thank you, Varun. So this is the final. After that, this is the final one, the building performance. So we have a building performance. The portrait compares building using today's consumption and daily capacity. For example, the library. The library had 420 kilowatt and 68% of daily capacity. The academic block has 680 kilowatt and 82%, and the hostel had 530 kilowatt and 61%. While the laboratory is a 720 kilowatt and 94%. That immediately tells that management that the laboratory deserves greater attention because its consumption is closest to its daily capacity. The final value of EcoCampus AI is therefore not the dashboard itself. It creates a completion cycle. First is the collect data, then is a monitor performance, dictate anomalies, predict future demand, recommend actions, and measure potential savings. So from an ETB perspective, this demonstrates how emerging technologies such as IoT, cloud computing, analytics, and AI can transform operational data into managerial intelligence. Management can then make better decisions about where to intervene, which building to prioritize, how to reduce energy costs, and how to improve sustainability performance. In short, EcoCampus AI aims to change campus energy management from what did we consume to what is happening, why is it happening, and what should we do next. So that's all about our project, and I hope you like it. Thank you.